Hello, welcome. We're going to do our next math lesson, which is measurement 8-13, volume of cylinders. This is found in your Jump Math workbook on page 157 and 158. So let's get started. The first thing is, it says calculate the volume of the prism. Now the cool thing is we've been practicing this already, and we know that the volume of a prism is simply volume, I need my pen tool. Volume equals the area of the base times the height. So they've given us the area of the base here, and the height is here. So the volume equals base times height. 3 times 8 is 24 centimeters cubed. The area of this rectangular prism is 6 times 5 because the base is 6, the height is 5. 6 times 5 is 30 centimeters cubed. The pentagonal prism and hexagonal prism, I'll let you do those on your own. You have the area of the base and the areas of the height included. And when you've done those, you can continue with this video. Let's check out this gray box. A cylinder is like a prism, but with circles for bases. And we actually have a diagram of a cylinder here. We've got a circular base, and we have a height. So a cylinder then is a prism with a circular base. Let's check out the investigation here. What is the formula for the volume of a cylinder? Part A says, predict the formula for the volume of a cylinder in terms of its base and its height. You know, my prediction is going to be the same as every other cylinder. It's going to be volume equals the area of the base times the height. And the reason I'm doing that is because it's worked for every cylinder so far. Doesn't matter what shape the base has been. Part B says, the volume of a can of food is given on the label. Bilal estimates the inside radius and inside height of 4 cans and creates this table. So let's finish off this chart here, shall we? If the radius of the pea soup can is 4.8 centimeters, the radius squared, we can find that with our calculator. We'll just go 4.8. I have to turn on my calculator. 4.8 squared. And 4.8 squared is 23.04. That's what I'm getting anyway. That sounds about right. Now what about the next one, 4.1? I'll square that one. I get 16.81. Mixed beans is a lot easier because that's a nice even number. It's going to be 4 times 4, which is a flat 16. And tomato paste is 2.5, which when we squared is 6.25. The inside height of the can is given in the next column. So the height times the radius squared is 11 times 23.04 for the first one. So we've got 23.04 times 11. So the height times the radius is 253.44. And it says the volume of food equals 796 centimeters cubed. Volume divided by the height times the radius squared. So we're going to go with 796 divided by 253.44. And I get 3.14078. I'll just round it to 3.14. Let's come up with this one here. So height times the radius, we'll go 16.81 times 13. I get 218.53. Well, let's divide 680 centimeters cubed divided by 218.53, and I get 3.11. And the next one is going to be 16 times 10.8. I get 172.8. So let's divide 540 by 172.8, and I get 3.125, which is 3.13. Let's try the next one. 6.25 times 8. My height times the radius squared is 50, and I can do 56 divided by, 156 divided by 50, and that is 3.12. Now, it says Bilal measured the outside height of this pea soup to be 11.8. Why did he estimate a smaller number for the inside height? So why would the inside height of the can be smaller than the outside height of the can? Well, I'm guessing because the can itself takes up some of the space, right? So the space or the volume that the shape takes up is going to be the amount that's in the can plus the can around it, right? The can has height. So the capacity of the can is going to be slightly shorter than the height of the can. Bilal measured the outside diameter of the pea soup can to be 10 centimeters. And what is the, let's go back here. What is the outside radius? Well, if the outside diameter is 10, the radius is going to be half of 10. That's 5 centimeters. Why did he estimate 4.8 centimeters to be the inside radius? Okay, well, the can takes up space, right? Just like with the height. Now, we've already done the table. That's already done. Which column has values always close to pi, which is about 3.14? So if I take a look back at the table, here, I can see volume divided by the height times the radius squared is very close to pi all the time. That was, whoops, make my pen smaller. Let's erase this one here. Okay, so that was volume divided by the height times the radius squared. Now, we want to use our answer in D to write a formula for the volume of the can. So the pi is equal to the volume divided by the height times the radius squared. So the formula for the volume then equals the pi times the height times the radius squared. The base of a cylinder is, of a circle is with radius, let me reread that. The base of a cylinder is a circle with the radius of r. The area of the circle is, always pi times the radius squared. So if we use our answer of f to rewrite our formula for from E for the volume of a cylinder, the volume of the cylinder equals the area of the base, which is pi r squared, times the height. Now, how is the formula for the volume of a cylinder like the formula for the volume of a prism? It's just the area of the base times the height. And that's what our prediction was, is that the area of the base times the height would be the volume of the cylinder. So was our prediction correct? Yes, of course it was. We're brilliant. Let's move on. Now here's where we get to actually put this into practice here. The volume of the cylinder is equal to the area of the base times the height. We're going to find the volume of the cylinder. So they've given us the area of the circle there, and the volume is there. Well, this is easy enough. So I've got the area of the base times the height is 12 times 3, which is 36 centimeters cubed. What about this one? The area of the base is 20 and the height is 6. 20 times 6 is 120 centimeters cubed. I'll let you do C on your own. Then we'll take a look at number 3. Trying to erase that little pen mark there. Okay, let's take a look at this one here. Number 4 says, Tina has a jar 20 centimeters high. So right there, we know it's 20 centimeters high. She can fit 30 candies flat on the bottom of the jar. Each candy is 1 centimeter high. How many candies can she fit in the jar if the jar is a cylinder? So if the jar is a cylinder and she can fit 30 candies flat, then it's going to be the area of the base, which is 30, times the height. So it's going to be 30 candies times 20 layers. 30 times 20 is 600 candies. What about if the jar is a right prism? Right prism, again, it's the area of the base, which is 30 candies. There's 20 layers, 600 candies. Are the answers the same? Yes. Why does this happen? Well, because volume, no matter the shape, equals the area of the base times the height. Let's take a look at the next question. All right, here we go. Number 5 says, regular polygons with many sides look a lot like circles. Some Canadian pennies are circular, but some are polygonal. That means they've got straight sides. So this is a circular penny and this is a polygonal penny. Estimate the volume of a penny by pretending all pennies are perfect cylinders. Step 1, measure the diameter of the penny. So you're going to use a ruler if you've got one, and you're going to measure the diameter of this penny. I've got a ruler here, so I'm going to use my workbook, and I get the diameter as exactly 2 centimeters, 2 centimeters, which is 20 millimeters. Step 2, calculate the radius of the penny. Well, the radius is half the diameter. So the radius is going to be half of 20. That's 10 millimeters. Measure the height of the penny. Wow. They don't really give us the height of a penny, but I've got a penny in my drawer here. The height of a penny is about 2 millimeters. I think I'm doing this right. Next, measure the height of 10 coins by stacking them. Then divide your answer by 10. So the height of 10 coins stacked, well, that's 20 millimeters, so that's 2 centimeters divided by 10. What? 0.2? I'm just figuring this out here. Give me a second. Oh, I made a mistake on the other one there. If it's 2 centimeters divided by 10, it's 0.2 centimeters, which is equal to 2 millimeters, not 0.2 millimeters. That looks better. Okay, let's take a look at number 4. Calculate the volume of the penny using the radius and the height you found. Okay, so the radius then was 10. Pull up my pen here. The radius was 10. And the height was 2 millimeters. Okay. And we're going to use our volume for a cylinder, which is volume equals the area of the base, which is pi times the radius squared times the height. Okay, because we need the area of the base. So the area of the base is pi times the radius squared. So it's 3.14. Use my calculator for this. Times 10 squared. I get 314. And the height is 2. So times 2. So that's going to be 628 millimeters cubed. That's my volume of 1 penny. Sarah fills a graduated cylinder to the 30 milliliters mark. She then adds 10 pennies. Where should the water level be now? That one I'm not sure. Where have we gone from millimeters to milliliters? I'll pause it and come back. All right, I was just having a moment there. When we're taking a look at volume here, 628 millimeters cubed is equal to 0.628 centimeters cubed, because we're dividing by 1,000. Now, each centimeter cubed is 1 milliliter. So if she's adding 10 pennies, she's adding 10 times this number. So 0.628 times 10. And we're going to use our calculator for that. And she's added 6.28 milliliters. And she already had 30. So the water level should be at 36.28 milliliters. Wow, that was a pretty big jump at the end with that problem solving. But I think we're going to come back to that one in the next lesson, which is on capacity. And we're going to be doing some conversions between milliliters and centimeters cubed. That's it for today.